Hi everyone, welcome back to my YouTube channel Chemistry with Sumitpramar. Today we'll be solving past paper from year 2018 October-November series, paper code 970111. Let's look at question number 1, which says the first 4 ionization energies for element X are shown in the table. Which ion will be produced by removing one electron from a completely filled shell? Filled shell means completely filled shell. If I look at the data of ionization energy, we can see that there is a huge jump from third to fourth ionization energy. That means there are 3 electrons in the outermost cell. There are 3 electrons in the outermost cell, and the inner shell will be completely filled shell. So if we want to remove one electron from a filled shell, that means we need to remove 3 electrons first, these 3 electrons first, and then we can remove one electron from the completely filled shell. So the ion that will be produced will be X4 plus ion. Now let's look at question number 2, which says what is the basic assumption of kinetic theory of gases for an ideal gas? For an ideal gas, the basic assumption is the particles of gases collide in such a way that the energy before collision remains equal to the energy after collision. That means energy remains conserved. Energy remains conserved. This type of collision is called elastic collision, as you must have studied in physics. So option A is the correct option. If you look at the rest of the 3 options, these are incorrect for an ideal. Question number 3 says a sample of hydrocarbon C6H12 is completely burned in dry oxygen. If I burn C6H12 in presence of oxygen, it gives C6CO2 plus 6H2O. And if I want to balance oxygen, I'll put 9 here. That means equal number of moles of CO2 and H2O are being released. So the product gases contains H2O, CO2 and excess O2. When these product gases are passed through these vessels, in vessel P, we can see that it contains anhydrous calcium chloride, which absorbs H2O. After passing through this vessel, the product gases passes through vessel Q, which contains soda lime, and it absorbs CO2 and excess O2 is released. Now the question is asking the increase in mass of the collecting vessel P, this is vessel P, and Q, this is vessel Q, are MP and MQ respectively. What is the ratio of MP and MQ? We know that the increase in mass of MP, this P, will be because of absorption of H2O, and that means it will be in multiples of molar mass of water, molar mass of H2O, because water has been absorbed. So whatever is the increase in mass, it is because of H2O. Similarly for this one, the increase in mass is because of absorption of CO2. So the mass that has been increased, it will be in multiple of molar mass of CO2, which is 44, this is 18. So if I find out the ratio of MP upon MQ, it will be in this ratio 18 upon 44, which comes out to be approximately 0.41. Hence option A is the correct option. Question number 4 says 5 gram of sample of carbonates of barium, copper, lithium and magnesium are decomposed to metal oxide and carbon dioxide. For which compound is the greatest loss in mass? Let's write down the equation. Barium carbonate BaCO3, if it decomposes in presence of heat, it gives you BaO plus CO2. Similarly, CuCO3, if it decomposes, it gives you CuO plus CO2. Lithium carbonate Li2CO3 decomposes to give Li2O plus CO2. and magnesium carbonate MgCO3 decomposes to give MgO plus CO2. So we can see that all of these carbonates are releasing same number of moles of CO2, right? Now for which of these the loss will be maximum? So the salt which has the least molar mass will have a maximum loss. This is similar to an example. For example, if someone has 100 rupees and if the person loses 5 rupees, that won't be a significant amount of loss. But if a person has 10 rupees and if he loses 5 rupees, that will be a significant amount. So the person who has lower value, if he loses same amount, this one will be a bigger loss. Similarly, in case of salts, if I calculate the molar mass of BaCO3, it will be 197. If I calculate the molar mass of CuCO3, it is around 124. For Li2CO3, it is around 74, and for this one it is 84. We can see that the molar mass of lithium carbonate is smallest, hence if it loses 44 gram, that means CO2, the mass of CO2, if it loses 44 out of this, that will be a biggest loss as compared to this one loses 44 and this one loses 44 and this one loses 44. The biggest loss will be for Li2CO3, hence the option C. Question number 5 says consider methane gas as an ideal gas, and we can use this equation, ideal gas equation, PV equals to nRT. The volume of the sample of gas has been given. This is the volume. V is 5.37 into 10 raised to the power minus 3 meter cube. Temperature T is 60 degrees Celsius, which can be converted into Kelvin by adding 273 plus 60. It comes out to be 333 Kelvin. And pressure P is 103 kilopascal, which can be written as 103 into 10 raised to the power 3 Pascal. Now we know that PV equals to nRT. N is equal to mass upon molar mass. So I can rewrite this equation as PV equals to mass upon molar mass into RT. Since we need to find out mass of the gas, I can transpose the rest of the variables. M is equal to PV into MR upon RT. If I substitute the values of pressure, volume, MR and R and T, P is 103 into 10 raised to the power 3, V is 5.37 into 10 raised to the power minus 3, MR for methane molecular formula is CH4 and the mass is 16. So 16 upon R is 8.31 into temperature is 333. If we calculate this value, it comes out to be 3.2 grams. Thank you for watching my video. Please like, share and subscribe to my channel, Chemistry with Sumit Pramar.